Firstly, good morning, good afternoon and good evening. Welcome to today's session, BIMREC webinar 17.0, Discover the True Meaning of Open BIM. What are you going to take away from today's session? Well, during today's webinar you will discover what Open BIM is and why it's so important for the AEC industry. Learn about the role of data sharing in collaboration. You're going to learn about issues in integrated BIM, technology, work processes and business models. You're going to discover the latest in UK BIM levels 2 and 3, federated domain models or a central model. Now, as for how this webinar is going to benefit you, well, the topic of today's session is Open BIM. It's closely related to the integrated BIM projects and the question of whether the team must use the same BIM software or if they can use the tools of their choice. This is really crucial, especially for smaller companies which cannot simply afford the multiple softwares. It's also as important for larger organisations because the different software products have different strengths and one software is not necessarily the best tool for every task. Now there is a lot of misunderstanding when it comes to the use and usability of OFC, data transfer and about model servers, which Arto's presentation will cover. Today's session should last between 50 to 60 minutes long. It's going to be split into two sessions. There'll be a presentation followed by a Q&A towards the end. I will be hosting along with Arto. As always, we do have a ton to get through, so we're going to move really quickly and take questions towards the end of the session. Stay to the end for the Q&A and we can answer any questions you may have. For everyone live on today's webinar, at the very end of the Q&A, I will provide links for today's slides with Arto, a link for our next webinar with Nick Nisbet on Wednesday the 25th of November. If you like the recording of today's sessions, copy of any questions, links for previous webinars, or to schedule a call via my online diary for any BIM recruitment inquiries, please type your name and details in the chat box to the right hand side of your screen, and I shall make sure that everything you require, that you receive everything you require as we move through today's session. Now, with the BIMREC webinar series being an open invitation series of events, we've had a lot of new people attending today, so welcome. For those of you who don't know me, my name is Barie Hasib. I am the Managing Director of BIMREC and AEC Recruitment. BIMREC are an essential recruitment partner for individuals and organisations really looking to win with BIM. We're really passionate and devoted to helping our candidates, clients and the industry overcome any obstacles throughout your entire BIM journey, whether that's helping you personally with a team hire world-class BIM talent or offering these online educational workshops with BIM leaders. For those of you who are new to this series of BIM webinars, we are often asked why have BIMREC put together this series of free educational workshops? Well, whilst extensively surveying our candidates, clients and the marketplace, we discovered our industry still has a real long way to go with regards to BIM. So what better way to help educate than bring BIM leaders directly to your desk? As you know, BIM is a journey. Some companies and individuals have had great success, whilst for others it's been a real steep learning curve, or they are yet to even start out on their journey. Our goal, whatever the level you're currently at, is to simply really help you win with BIM, whether that's for our recruitment expertise or helping ensure candidates, clients and the marketplace have access to world-class leaders who are experts in their fields. That's certainly the case today. Today I'm very proud and privileged to announce we have Professor Arto Kiviniemi with us. Arto is one of the most internationally recognised experts on integrated building information modelling, which he has developed both in Finland and internationally since 1996. Arto's main activities have been related to the International Alliance for Building Smart International. Arto is one of the founding members He has acted in various positions from Technical Management Committee through to Chairman of the International Council and Executive Committee. Arto is currently a member of the International Technical Advisory Group and the Professor of Architectural Design at the University of Liverpool. Arto is presenting today on Discover the True Meaning of Open BIM. With that said, I would like to unmute Arto, and Arto, make Arto the presenter.
And I will share my screen now, and so also good morning and afternoon and evening also on my behalf, and thank you, Barie, for the opportunity to speak to this audience. And as said, the true meaning of the Open BIM, there are quite a lot of misunderstandings about the topic, and therefore I will also have some rather critical views about the Open BIM. And I also want to mention that the presentation is very much based on the material that we used in the BIM show live in 2015 in Manchester, which actually was got the reward of the best presentation in the conference. And my co-author and in Manchester also the co-speaker was Leon van Berlo, who is one of the key developers of the BIM servers based on the Open BIM technology. So I wanted to include his credentials and in this presentation as well. And then when thinking about that, what is really the Open BIM? I took some definitions, and I'm not going to read all the text that I'm having in some of my slides, but the main thing there is that it's a standard, a common language for the BIM software, so that we can share the information that we create in different tools and reutilize that information in the processes using different types of tools. And the Open BIM, the most common Open BIM standard, is based on the Building Smart Data Model, IFC, Industry Foundation classes. And why it's important? First of all, it's really important that we have these open workflows which allow project members to participate regardless of the software tools they use. It's not very good model if everybody has to commit to use the same tools, because our industry is very fragmented, and also, as I will be pointing out later on, there are very different needs when we think about the model content. So as Barie already said, that the same tool is not necessarily the best tool for everything in the process. So basically we are creating a common language which can be used throughout the whole industry, and also outside of our industry, like governmental clients. And part of this is also the procurement. We should really select the team so that the client will get the end result that he is expecting from the design and construction processes, and can utilize the data that we produce in those processes also in the operation and maintenance of the buildings. So this is something that it's avoiding the unnecessary recreation of information. And Open BIM is something where all software vendors are welcome. So it's not only for some leading software vendors, there are actually quite a lot of very small tool developers who are also part of the development. And the basic idea really is that everybody can select the tools that they think that is best for the task that they are doing there. So also the product data is important part of this, because if we want to have the life cycle information, we can't expect that the project team will be producing that information. We have to get the basic information about the products that we are using in the buildings from the manufacturers, and also that is part of the Open BIM. So if I go back to the history, this is from the national program that I led in Finland in 1997-2002, and the basic reason for going to the BIM and data exchange is this situation that we had there, and still often today have, that we are using computers, but we are exchanging the information on documents. even if they are electronic documents, they are still only human readable. And that means that we have to recreate the information so that the others, that we can use the information that others were producing in our processes. And this is non-value adding work. It's causing friction, data losses, and also easily additional errors in the processes. And this is not a small issue. There was in the mid-90s a study in the UK that was saying that every bit of information that we have in the construction and design processes is recreated 7 times in the process. And that means that we are really wasting a lot of resources in that process. So the basic idea of the integrated BIM is that information is shared in the exploitable data format between the different systems, which means that the information must be computer readable. Computers must be able to understand the semantics of the model that we are sharing. And when we are in the drawing environments, traditional document environment, it's not possible for the computers to utilize that information because it's really, as said, human readable. Then one of the things that when we started the IAI, now called Building Smart, this is one of the basic images that was used already in 1996. This slide is from, as you can see, from 1999. And there is one fundamental mistake in the image, because it has been creating the misunderstanding that we would really have a shared project model where everybody is working. So the image that many people have is something like this. And this is really a misconception of integrated BIM, that there would be one database, one model where everybody is working in the same model. So this is something that I would say that we should forget when we think about the integrated BIM. It's more like data flow through the standards, so that we don't have to build the data interfaces between every different software that the participants are using. But we have a common model, a common language that is used for the communication between the different software products. But it doesn't mean that there would be a central model. I will go to details a little bit more. And in a way, it's a similar thing as if you think about the spoken languages. Here I have some examples of the name of a chair in different languages. And of course, it is something that if everybody is using their own language, they know the language better than any other language. Usually nobody is speaking any foreign languages as well as their native language. But it's not communication, everybody is using different language. And in the software products, we have the same situation, that every software product has different internal language. To be able to communicate, we have to agree about the standard. And in the spoken language, English is now becoming a lingua franca, a common language that we are using. One big difference, though, is that in the human communication, we are very flexible. So everybody recognizes immediately that all these are chairs, even though they are very different. Computers cannot do that. They can't recognize the purpose of something the same way as we can. And therefore we have to be much more exact about the definitions. That's why we have these standards and classification systems, so that we can communicate inside the software products, so that there is a same understanding of what is the meaning of the object that we are using there. Then these BIM servers have been something that there has been a long development. Actually, the first BIM server started already inside the Finnish program that I was leading in late 90s. Yoshinobu Adachi came as a visiting researcher from Japan to Finland and built the first BIM server based on databases. And then I think that the leading product at the moment and in this area is TNO's BIM server, which is an open source server, everybody can get access to that, so it's not a commercial product in the traditional way. And they started to develop this to be able to share that information. And as you can see, 2009 was the first release, which was utilizing the common language, the IFC model, and was also web-enabled, of course. And when they started to test that, they had a pilot project where they wanted to test certain features, certain possibilities of that. Look how the information flows in a project, and also how which tools are used. And the basic idea was to compare the homogeneous software environment to this environment where everybody can use different software products. And as you can see from this diagram, the environment was relatively complex. They used several different software to test how well it works. And from the tests, they also made a report, which you can nowadays find also in the web, about collaborative engineering with IFC. And some of the main findings there was that there is no central model. So the whole idea that this image about this one central model where everybody is working, it's not feasible. It doesn't work. On a project level, we can't have one central model. So basically, we have a situation that every domain, architects, engineers, construction companies, owners, they have their own central models. But why? This is something that I'm quite often in discussions with people who claim that this is just a technological flaw, that when the technology is developing further, we will have one more central model where everybody will be working. I don't believe that that's going to happen ever, and now I will be trying to explain why. First of all, we have to start with thinking about what is a model. There are very many different models. This is a process model. This is a mathematical model, scale model, which is of course very, very common in the construction industry. If you speak with the people who are outside from our industry, very many people think that this is a model, a fashion model. And then of course we have the BIM, Building Information Model, and many, many, many other models. Why do we call all these things as a model? What is the common thing? The best definition I have ever found about how to define what is a model is from the artificial intelligence, Seth Rothenberg's definition from 1989. A model represents reality for the given purpose. Model is an abstraction of reality in the sense that it cannot represent all aspects of reality. This is something that I always teach to my students when I start teaching BIM, because it's very fundamental thing to understand the information sharing in the model environment. First of all, it means that different domains, architectural design, structural, HVAC engineering, construction task, facility management, they have different models because they perform different tasks. For example, in the architectural model, one of the very central objects is space, the purpose for the building. But in the structural model, there is no such object as a space, because from the structural viewpoint, it's not important. And the same way, we have a lot of different things that are very different in different domain models, and combining them in one model is basically impossible task. And then when we think about the integrated project working, we have a shared model where we share the information which is necessary for the design coordination. But also defining this is much more complicated than it looks from the surface. That's why the development of the IFC and the practical implementation of that has been taking so long time. It's not easy to build a common language between the different software products, but because the differences are so big. Again, it's similar with the spoken language, so that the languages are not either one-to-one. In one language, one word can have very many meanings, and which are different than in other languages, so translation between the languages is not simple either. And when I say this, is this claim that there is no central model or it's impossible to work in one model, is it just my opinion, or is there some evidence that it's showing that I'm right when I'm making this claim? There are actually quite a lot of research on that. So this is from Denmark from 2006, where they were looking at the working environment. Later on they made another test in 2008, the same basic principles there, that you have to have these discipline models, and then for the coordination purposes you combine them. Also Tekla, one of the leading structural engineering company, has been using this, the idea that the shared data would be the master model is a misunderstanding. Those people who think that this is the master model is the shared information, they always say that if you use the IFCs you lose data. And that would be the case if the master model would be the shared model. But in fact, the master models are the individual domain models, and then the IFC model is published for the sharing purposes, so that the other people can access the data that we have been producing in our proprietary models. So this is again something which very many research projects and also practical implementations have been showing that we have to follow this model. Also in Netherlands there was similar project as in Denmark that was coming to the same conclusions, that these proprietary or domain models, they are a central part of the workflow. And of course this is from the logical viewpoint, this is something which is absolutely necessary, because we can't think about the situation that the architect would be changing the structural model, or the structural engineer would be changing the architect's model. We have to have the responsibility and ownership of our own data. That's a necessity. So, and of course also when people claim that, for example, car manufacturing or airplane industries have one model, they are wrong. In fact, they have sometimes thousands of submodels which are on a very well integrated platform, but that's not one model from the conceptual viewpoint either. So observations from when you approach the sharing the data in the right way, that there is no loss of data using IFCs, because the original data is always in the original model. It doesn't disappear anywhere. It might be that there are some things that are not easy to share with using the IFCs, but it doesn't mean that they would disappear somewhere. And if there is something like that, then of course we have to develop our IFC interfaces further, so that we can cover the things that we need. But I would say also that currently the IFC is covering the data sharing needs quite well. So when they made the several tests, there is not a single IFC loss of data issue in the experiments. So IFC is definitely usable. And one of the problems that they found out in the Netherlands in the tests was that if you are using the homogeneous software environment, so that everybody is using the software products from the same family, then they felt that team members must be much more on the same level in the modeling. When you use the IFCs, it's allowing more flexibility with the skills and expertise of the different players. Also that when we use this reference model concept, meaning that we are utilizing the other models only as a reference inside our modeling environment, not trying to modify that information, is that we can really agree about what is the sufficient level of competencies that we can handle the issues that we have in that environment. we can't help that in this transitional situation where we are now, that there are quite big differences in the BIM competencies among the teams. And I think that this is in a way no-brainer, but still I want to emphasize it that we should be selecting our project partners based on the design competence rather than the software that they are using. Because the end result, what we try to do, requires the professional skills, and the software is just a tool to make that happen. And the reference model is something that sometimes it's confusing people, that what we mean by that. And this is just a very simple example of that when we have the architectural model and an engineering model, on both sides, the other one is the reference model. So the architect can load the engineering model into the architectural model and compare for example, the dimensions and locations of the different objects with his designs. And vice versa, the engineer can take the architect's model and compare that. But they are not necessarily exactly identical. Of course, sometimes there can be some design mistakes, that there are really conflicts between the models, but it can be also that the practices in the industry are different. That, for example, the architect can be modeling with nominal measures, and the engineers are using the actual measures, so that they can be slightly different sizes. And again, it's something that we have to agree on the project level. What are the ways of modeling? What is the correct level and correct accuracy of the models? So basically, the conclusion from the tests both in Denmark and Netherlands was that working or trying to work live on a central model servers has more downsides than advantages. Because if we start putting all the objects in the same model, the ownership is difficult to manage. There can be the copyright issues, intellectual property right issues. We need a very competent BIM manager, and then who can change and how to handle the changes is quite challenging there. It doesn't mean that the BIM server would not be useful. BIM server is a very good environment to publish the shared information for the project team, but it doesn't mean that we would be working on that. We are publishing the information when we feel that it's useful for the other project partners. And for that, BIM server is a very good environment. So, in a way, if you think about this image that I had earlier, the central model and working there, when we think about this, the real situation is much more like this, that we have these domain-specific BIM tools, and the integrated BIM means that we are sharing the necessary parts of our models with our partners. Not everything. There is no need to share all the data that we have in our domain models, because only part of that is relevant for the other participants. And this is also important to understand when we think about the workflows. And when we think about the real environment where we are working, it's actually even more complicated than the previous image. It's not just the project model. This is basically the same image that I had before. Integrated project model. But when we think about our working environment, inside our companies, we have also information and databases and libraries that are shared between the different projects where we are working. So they are company-specific information. And this project-specific information is utilizing that. Example of this is, for example, the cost estimation process in the construction company. They should use their cost databases, which are maintained on the company level, to calculate the project costs. But if you start embedding the cost information on the project level, it's very difficult to maintain when the prices are changing, for example, material prices or labor prices are changing, you have to remember to update that everywhere. And that's not the way that we should work in the BIM environment, where one of the central principles is that one piece of information is stored in one place and then linked to the other places where we need that information. And when we take the full picture is that these internal databases and libraries, they are also connected to the common databases and libraries. It's very usual practice that we are taking, for example, the product information from libraries that are published either by the National BIM Library project or the different manufacturers, and then we either copy or link them into our own libraries and use them in our project environment. So to me, integrated BIM is actually a network of information coming from different sources, so that it's easy to maintain and update when we need to make changes in any part of the information that we are utilizing. Then, as promised, a little bit about the UK Level 2, Level 3 BIM, because it's closely related to the topic. You probably all have seen this image about this very famous wedge about these different levels, Level 0, Level 1, Level 2 BIM. And in the UK next year, the mandatory part will be that all public projects made for the government are required to use the Level 2 BIM. And there has been a lot of development, a lot of guidelines and standards around this issue, so that the industry should be ready for the use of BIM on this level next year. However, there is one thing that I have been actually discussing quite a lot with Mark Pugh and David Phillip, who are leading the implementation of BIM here in the UK. And it's related to the situation that government is requiring in the strategy that it's fully collaborative 3D BIM with all the project and asset information, documentation and data being electronic next year. For some reason, they still wanted to keep the IFC on Level 3, as you can see in the wedge. And to me, that is actually not the case. If you really want to have a fully collaborative BIM, especially on the public projects, you really have to include the IFCs there as well. And of course, many projects in the UK are using already IFCs. It's just that it's not formally required in the project. But if you speak about the public procurement, it's impossible to require that people are using certain software. So the only possibility to have the collaborative BIM is to use the standards. So IFC will inevitably be part of the processes if we really want to implement integrated BIM. Then when we think about the Level 3, it's something in the future. It's not defined, or there was a long time that it was not very well defined, and there was a lot of discussion here in the UK that many people were saying that on the Level 3 we have to work in one model. So that in Level 2 it's federated models, that we still have these domain models, but in Level 3 it will be one model. And I was really concerned about that if that would be the definition, because as said, I don't believe that it's from the process viewpoint possible. Technically it's possible, but it's not something that we should be implementing. And therefore really my view has been that it cannot be that. And I was very happy when I saw the latest developments, how the Level 3 is now defined. This is from Mark Pugh's presentation last spring about the Level 3 BIM. And Level 3 BIM, as it defined now, is extension of this network of information, so that we are not speaking only about the buildings, but also transportation, water, power, people. We are building a very comprehensive model of the built environment and linking the different information sources together. This is something that this is of course a huge task to build this kind of a working environment where we can utilize the big data from different sources. But this is something that it's ongoing work, and this is definitely the direction where we should be moving. So it's not only about individual buildings, but buildings as a part of the infrastructures, the service structures and activities that we do in the built environment. And this is the vision that is now here in the 2025 strategy that the government has been implementing, and they are the next steps after the 2016 level 2 BIM implementation. So, as I said, let's forget the idea of the central model server, but then about the data sharing and collaboration. Some thoughts about that. First of all, it's really the collaboration now. The reference model is used very widely. And as this Leon van Berlo's image is showing, that he's saying the working with IFC is like sliced bread. Very simple, handy thing to have. And it's really not complicated when you are building the right working environment for you. And BIM is not a goal. Collaboration is more than just sharing data. And I really like this image from Leon, which is saying that really just putting your data available for others, it's not the right behavior. We can't replace the human communication by just putting our data available for others. We have to have the human collaboration as well. So the right model is as I use very often this image, that Sutter Health, which is one of the big hospital owners and insurance companies in the United States, they have done these IPD, Integrated Project Delivery projects, now for about 10 years. And their slogan is collaborate, really collaborate. Not just speak about that, but really collaborate. And they have been implementing this big room environment where all the designers are in the same space, and also the construction companies, and the decisions are made in collaboration and collectively, optimizing the whole project instead of minimizing the workload of different participants. And when we think about the building design, it's important that we really recognize fully that everybody is bringing their own expertise to the collaboration. There is no such person who would be able to design a modern building alone. It's much too complicated. We need the different professions. And we have to really start thinking much more about that. What do we need to do our job, and what do the others need from me to do their job? Unfortunately, this is something that our industry is not very good in understanding in holistic way the processes. There are quite a lot of challenges in this area. One is that really when we think about the traditional processes, we are very often producing the information too late. This is from a project when I was working still at VTT, Technical Research Center of Finland. We analyzed some of the BIM processes. And this is about the problems. There were of course also some benefits there. And typically the problems were related to the process or the skills of the people there. And most often the information was produced too late so that it would have been serving the decision making and other design processes. So we have to re-engineer our processes, rethink the data flows. But unfortunately we are, like this image, very much focusing on our own tasks. We have had very standardized roles, which was one of the strengths in our industry in the past, but now it's becoming an obstacle because we have the situation that the work processes are changing, and then the roles are changing. And the old models that we have in our heads are preventing us to see the holistic view. In a way, we are like this fable of the blind monks investigating the elephant. They were touching the different parts of the animal, and of course everybody was describing the animal totally differently because none of them could see that animal. And that's in a way, the way that we are working in the construction industry now, that everybody knows his own piece of the work, but nobody is really seeing the big picture, or very few people in the world have been really having a holistic view about the processes, how they should be in the new environment, because it's very different process compared to the old paper-based environment. It's also, I said that it's not a simple thing to make the common language, because if you think, just take a typical architectural view of the building. Of course, nowadays this is just a user interface to the model information, but still we have these building objects in the architectural model in a certain way. For example, the walls have dimensions. But if you want to use this for the thermal simulation, the view is very different, because all the thermal simulation software are using only surfaces. So the walls can't have thicknesses in there. So it's very much simplified view of the building. And we have to make this transformation between the different views when we use that information. So it's not always one-to-one. And this is a challenging task there. And one of the questions is that how to do that transformation. Do we do that when we export the information, or do we make the transformation when we import that information? Personally, I'm favoring the latter one, because the receiving software knows what it needs. On the other end, the sending software doesn't necessarily need what the simulation software is needing, and not every simulation software is using exactly the same data. But there are different views about this thing. Some people think that we should have the exact exports for certain purposes. But this is one of the challenges that we have to face. Again, I want to remind that it doesn't mean that you couldn't use it. It's just that it requires quite a lot of programming to build the interfaces between the different software products. Also, one of the big challenges is that the objects are not necessarily the same in different models. Multiple objects in the architectural model can be a single object in the structural model, or the vice versa. And if we want to then really link the objects together so that the software products know that this is the same real-world object which is represented in structural and architectural model, the creation of maintenance of the links is not a simple task. Also, I said that it can be that we are possibly modeling with different practices, so nominal contra the real measures. And also, it's even though we easily think that buildings are very simple, that you have walls and you have slabs and you have windows, not all buildings are like that. When you think about something like Frank Gehry's concert hall in Los Angeles, it's not so clear. Martin Fisher has often used the example that when you take, for example, the concert hall wall there, that you have a building envelope. It's one object in the architectural model, and in the beginning, below there, it's wall, and in the other end, it's clearly a roof. But where does it change? It's not easy to say that what is that, unless we just say that it's a building envelope. From production viewpoint, this was actually, in this case, 4 different production methods were used to make this one object in the architectural model. And these things make it demanding to define the common language. Then the last thing that I want to cover here is that the quality of IFC implementation. This is something that is almost always discussed a lot when somebody is speaking about the use of IFCs. There are lots of doubts about that. Can you really use the IFCs? So I just took a couple of examples from the internet about what people are saying. The other one is saying that IFC is not at all useful. The other one is saying that it works fine. Both people making these claims are very knowledgeable. Neither of them is lying. So how do you explain that you can have totally contradictory messages and both, in a way, are right? Why this is a thing that has happened? I think that one of the reasons was that earlier, especially earlier, not so much today, but earlier the understanding of the IFC was that it should be supporting so-called round tripping, which means that you should be able to take the architectural model to structural engineering model, to take the combined model to the MEP and give that to the construction, and then you could take that back to the architectural software and nothing would have been disappearing. But this is not possible. I said that there are no placeholders for all the information. If you put the architectural model in structural modeling software, you lose the spaces and many other things as well. And so round tripping is impossible. But many people think that that was the purpose of the IFCs, and if they think that it should be supporting this, of course they are disappointed because it can't do it. Also, IFC round tripping inside one domain, it doesn't work. If you take the native BIM in any of the modeling software, export that to IFCs, which is meant to be the shared reference model in IFC format. If you try to import that back to your software, I think that many people have been trying this. What is the end result? People expect that it should be the same model that you exported, but it's not. First of all, the environment where we are working is a parametric model. It's our working environment. When we make the IFC export, it's creating a static model. It's no longer a parametric model. So it's a snapshot at that time. And the reason for this is that the reference models are not meant to be changed. It's not something, when architect is sending his model as a reference model to the structural engineer, it's not the point that the structural engineer could be changing it. The point is that he can't change it. Because if there is something that must be changed, he must communicate with the architect about how to change it. And this is really the purpose of the IFCs, and this is very often misunderstood. It's not the purpose that you can export and import that file and it's still the same. Also, some of the IPR issues are solved with this because it's kind of you have not all the information that you have in the native model, because some designers are afraid of giving away the models because they think that there is some business critical information that would be then shared with others, and they don't want to do that. So the purpose of IFCs must be first understood correctly. So when I take the image that I had earlier, the idea is that we are updating the shared model from our native models, and we are never taking back our own information. We are only taking the data retrieval is only reference information from other models, but never our own. And if this is understood, then IFC's usability is understood correctly, and I said that you can use that there. Also, historically there has been quite a lot of problems with the IFC exchanges. So I'm presenting now something which is based on a study that I made in 2007, so 8 years ago, which was causing quite a lot of discussion inside the Building Smart because some people didn't really like about that. But as an end result, the certification system was improved significantly. And the situation is not the same now, but many people still remember the early days of IFCs where they were using the certified software and were not happy with the results. And that's why I wanted to present that. But I want to emphasize that this is not the situation anymore. So in 2007, there were 9 applications that had IFC certification. On purpose, I don't have the names of the applications there because I wasn't criticizing the implementation quality of the individual software. I was criticizing the certification process. And the average exchange was quite good. So if you can exchange without problems more than 80% of the information in the models, it's actually quite good. But unfortunately, this is not the whole truth. If you look at the different object types, there were test cases in all object types, and then when I analyzed how they were going through, there were some object types were relatively well supported by different applications, but especially spaces, doors and windows had quite a lot of problems. And only one object, pile, was all the test cases were passing in all applications. But when you start thinking about this on the project level, if you look at this, so that I have taken the three object classes here, spaces, windows and doors, where we had quite a lot of problems. And when you look at this, there are basically very few places where the test cases have been okay in all software products. That means that if you are using, let's say in your project you are using applications 1, 2, 3 and 4, it's probably working fine. It's explaining that why this other person was happy with the IFC implementation. If the other person is involved in the project where you have applications 5 to 9, it's quite clear that it doesn't work, because there are very few places where the objects will be transferred between the applications without problems. So this is depending on this was depending on the situation, that which software products you used in your projects. So that's why people had very different experiences about the usability of IFC. And of course, this situation in 2007 was requiring quite a lot of testing or problem-solving capabilities from the project team, and it wasn't a feasible situation for the project working, where the people are construction professionals, not software professionals. But as said, that now the certification is much better. So I want to emphasize that IFC does work. And even in the past, there were lots of projects using IFC successfully, but it just required that you knew a little bit more about what you did. As said, certification is now much better than it was. And when people are complaining that IFC is not good, it's not necessarily, and usually not never really the problem of IFC specification. It's actually quite good. Sometimes it's because people are modeling in the wrong way. And depending how you model that, it's also affecting the quality of the IFC. And also sometimes the implementation quality of the IFC interfaces, it's not necessarily perfect in every software product. So there are still some problems, but as said, that it's useful. IFC has been used since 2002 in real projects. Senate Properties started their first pilot project in 2002, and since 2007 they have been using BIM and IFC in all their projects. Also, I know that Skanska Finland is using IFC in their own production, not to the proprietary formats, even though they could do that. All public BIM requirements in the world are based on open standards, either IFC or COBie. And simply mandating specific software product in a public project is not possible, because it would be limiting the competition and it's against the laws. And of course also on the private project it can be limiting the participation. So I think that open standards, open BIM is very important part for the industry processes. Also, the more we use the IFCs, the better quality will we have there, because then the software vendors will hear about the problems and they will improve the implementation. If nobody is using them, of course, it's not worth for the software companies to invest into the implementation of IFCs. And I said that some of the complaints of that IFC doesn't work are based on misunderstanding. It's not meant to be a parametric design model. It's meant to be a static reference model. And as the last thing is that really, when you think about that, how many software products are supporting IFCs? This is from the Building Smart website. There are already 161 applications supporting the IFCs, and as you can see in many areas like structural design, we have 33 applications. Quite a huge amount of tools that we can select for the different purposes. So Open BIM is here. It's very important for the industry, and I really encourage you to at least try that in your projects. Don't think that IFC is somehow a theoretical solution. It's practical solution, and it's usable already now. And the more we are using it, the better tools we will have in the future. So, thank you.
Fantastic. Thank you, Arto.
Okay.
Thank you so much for a really informative overview of IFC and Open BIM. There's thanks coming in from the chat box as well. I know we do have a ton of questions to get through. So are you? I'll open it up as well to the chat box here. If people do have questions, please do not hesitate to put them into the right-hand side. However, are you fine at the moment to jump on with some questions? Okay, are all BIM software vendors engaging in the Open BIM concept?
I have a little bit difficulties to hear because I'm really actually very badly hearing impaired. But was it that the software vendors?
Yes, are all open
about the IFCs? I think that I would say that all major software vendors are supporting IFCs. Because it's really, as said, that the public requirements all around the world are based on the open standards, which means that if you really want to have the collaborative BIM, it means IFC. Sure. Because COBie is not a collaboration format. COBie is good for transferring the design and construction information for facility management, but the project team cannot use that. So basically, if you want to do that your product is usable for the public projects in those places where it's mandatory, you have to have the IFC support. So none of the big software vendors is out of IFC development.
Okay, fantastic, thank you. In a very competitive AEC industry, what is the level of engagement and trust in the concept? That's a question I can ask quite a lot, actually. Did you want me to repeat the question? Sorry.
There are very many levels, of course, about this, because are we speaking on kind of on the trust on the project level, or are we speaking about the trust of the industry as a whole? I think that on the project level, at least I've seen a lot of projects where the engagement and trust are on a very high level. Of course, the best examples are probably these IPD projects that are really very open-minded about sharing the data and using sharing basically all data, not only the design data, but also the financial data is shared in those projects. But then, of course, it's when we think of industry as whole, it's much more complicated issue, because there are lots of companies that are very protective about the information, and they think that sharing the information is against the financial interest, and that the competitors will get some benefits if they start sharing the information. So in general, I would say that in our industry, we don't have much trust and engagement. But I hope that BIM will be improving that.
It's strange how the construction industry is so tight-knit, isn't it? It's certainly interesting. And I think I had a session last month with David Gillings, and he was saying he's from a manufacturing background, and he's saying manufacturers share absolutely everything. Everything's always been open.
Yeah, but I think that really the big difference there is that in manufacturing industries you have very steady supply chains. When you find a good supplier, you are not asking in every project a kind of different people. Sure. In construction industry, the procurement, unfortunately, is often so that the clients are slicing the project in very small pieces, and then competing every piece, looking at the cheapest price for each design domain, each part of the process, and they never calculate how much the interfaces between those pieces are actually costing them.
Sure.
And that's why I personally think that these alliance models or the IPD type of project, they are the solution for this, because then you start creating this kind of long-term relationships where the trust can be built.
Sure.
If you every time are working with the different people, it takes a lot of time before you start really trusting fully to the others.
Sure, yeah, no, completely. Okay, fantastic. Thank you. As there is no modelling software using IFC directly, do you consider this a good or bad thing for adoption of Open BIM by the industry?
Well, I think that it's impossible idea to build a modeling software that would be based on the IFCs directly, because as explained, that IFC's purpose is to make a static model. It's not a parametric environment. And there was actually, when I was leading that national program in Finland, there was one software house that tried to build software so that the internal structure would have been directly using IFCs. And very soon they discovered that it's totally impossible idea, that it would be very inefficient software. So it's really not something that I don't think that we can ever think that we could build a software which is totally based on the IFCs. IFC is really meant for different purposes, and I think that the structure of IFCs is good as such, but as a file format, I think that we should probably start moving into the modern web technologies in that area.
Sure.
Using the semantics that have been developing in the IFC environment, but probably in the future, at some point, we need to use some newer technologies, because IFC is based on the STEP standards, which were developed already something like at least 30 years ago. Quite old technology when you think about the information technology. There have been a lot of reasons for that, and there are some really good benefits in using those. But I think that at some point we have to start considering using something else.
Yeah, no, okay.
But it doesn't mean that changing the structure, the semantic structure of the IFC is absolutely good.
Sure. If something isn't broke, don't change it, huh? Okay. How can we enrich the model with data from external specialists, i.e. data needed for HVAC calculations needed in spaces?
There are, of course, many ways of putting the additional information there. You can use the extended attribute sets in the IFCs, so you can include that already in the IFC files. That's one way of doing it. It basically requires only that the project team is agreeing about how to use that external data, what type of data you put there, how to recognize that, how to find that in the model. Another possibility, which I think that it's very useful, is to build links into the external information, so that we can use normal databases where that external information is, and those databases are then linked to the objects.
Sure.
The technology is fully there that you can actually do that relatively easily nowadays, and that's very flexible way. That's very easy to maintain that information. So I think it's the environment there is to do that. It's more about creating the processes where people start really doing it in practice.
Sure, yeah, no, that's okay. Questions coming from Chris. A major stumbling block is ownership of the data or responsibility for accuracy. Any thoughts on how this is to be overcome if the true potential of BIM is to be realized?
I think that this is something that you have to have preferably also say that the national BIM guidelines, where you are already defining the basic principles for this. And then usually you have to also on the project level to agree about the accuracy. I have sometimes heard that people say that BIM the models should be absolutely accurate. Yeah. And what is absolutely accurate? Especially when we think about the refurbishment project, that old buildings are never accurate, and modeling that exactly the same way as it has been built is not really feasible. So we have to I would come back to what I said about this, that the model is an abstraction of reality for a purpose. Yeah. We have to think that what is the level of accuracy that we need in this project so that it's useful. It's also different depending which part of building we are speaking. If you speak, for example, the steel structures, and we want to use the model for the manufacturing directly, then it has to be really accurate, because it's going directly to the machinery that it's building, making the steel parts. But if it's, let's say, on-site concrete structures, we all know that they are never exactly the measures that theoretically they should be. So depending what we do, and this requires understanding of the production processes. What is useful, what is needed.
No, definitely. Okay, fantastic. Questions coming from Michael. Most of the BIM discussion revolves around buildings. That's true, actually. Can you comment on the application to the civil land development industry, value-added opportunities?
Yeah, that's a very good question. BIM as a name is actually not very good, because it's referring to the buildings. I'm sometimes said that we should start speaking about the asset information management, because then all the built environment would really fitting into that. But there are already a lot of projects. Actually, in many countries, the civil engineering part is it can be even more advanced than the building side, because the automated machinery that can build, for example, roads or railroads, it's much more developed than in buildings, because inside the buildings it's much more difficult to use robotics or things like that. So BIM has a very advanced applications on the civil engineering and infrastructure side. And of course, in the UK, I think that it's one of the best examples in the world is the Crossrail project in London. I can't imagine any more complicated project than that. And that is totally based on the very advanced use of BIM.
The guys on that project are fantastic. I speak to quite a few of them on a regular basis, and they certainly know their stuff. They certainly know what they're doing. Okay, well, I'm conscious of time, so I'll try to make a couple more questions. That's it. A lot of people are saying thank you, by the way, in the chat box, Arto. So thank you. A fantastic presentation, a breath of fresh air from someone who actually understands BIM and how to implement it on a project. IFC has a way to go, but may provide the necessary link to make BIM work on projects where each stakeholder is using different software. That's coming from Barie. Thanks, Barie. Okay, fantastic. If we just stick to one more question, what is the economic incentive for people to spend a huge amount of resources developing, contributing to and adopting an Open BIM standard?
Well, of course, it's if I think about the typical end user, you don't have to really contribute much to that. It's basically, if you use BIM, you can use Open BIM as well, because it's already implemented in the software. But then thinking about people who are active in Building Smart or the software companies that are implementing Open BIM, they of course have to invest a lot to this, because as said, that it's not a simple issue. I think that the motivation in Building Smart, the motivation is really that people want to improve our industry. I think that it's very ideologic work in a way that when I think why I was involved in the Building Smart in 1996 when we were founding that was really that I was aware of the problems that we had in our industry. I wanted to get rid of those, and I saw that BIM is a solution for that, and to be efficiently using BIM, we need Open BIM. And for the software houses, some of them were there because it was very much supporting their business case, especially if you think that you have some specialized software. I would say probably the best example on that field is Solibri Model Checker. It can't work without the Open BIM, because the whole idea of the software is based on this possibility to check the models and use the model information. It doesn't even read any other formats than IFCs. So for some software houses, it's crucial part of their business case. For some software houses, it's more like something that they want to support their customers to do that.
Of course.
And of course, that effort that the software houses are putting into the development of the Open BIM, it's like any other software development, it's in the price of the final product. So the end users are in that sense paying also that. But I think that on the other hand, Open BIM is increasing competition in the software market.
Sure.
And that's keeping the quality high and the price is lower. So in that sense, we all are benefiting from the efforts in the Open BIM as software users.
Sure. Yeah, no, fantastic. Well, thank you, Arto. There's loads, as I say, there's loads of thanks coming in. There certainly is. A very informative webinar again from Gary. Thanks, Gary. Next webinar is on the 25th of November at 3 p.m. GMT, not BST, with Nick Nesbitt. Nick's presenting on BIM Level 2 and beyond, working with shared structured asset and information, so a good continuation from today's session in all fairness. If you have any questions for me at all, here's my contact details here. You can either send me an email or schedule a call with me via the online diary at bimrec.com/diary. With that said, I would like to once again say thank you, Arto, and thank you everybody for attending. And that you're more than welcome. Thank you. The slides and everything will be available in a moment. As soon as I close down this webinar, a pop-up box will appear. Within that pop-up box will be links to Nick's webinar plus the slides for today's session. With that said, thank you once again, Arto, and thank you everybody for attending. I look forward to welcoming you all on the 25th. Thanks again. Take care, everybody. Enjoy the rest of your morning or afternoon or evening. And thanks again, Arto.
Thanks.
Thank you. Take care.
Thank you.
Yeah,
Bye-bye.